National Research Centre is a unique collaboration between 17 companies and 8 academic institutions, and will help to position Ireland as a global hub for pharmaceutical process innovation and advanced manufacturing.
Hydrogen peroxide, H2O2, decomposes into oxygen and water. Potassium iodide to act as a catalyst. I'm going to take my hydrogen peroxide and I'm going to pour a fixed volume of it into this. I will then take some washing up liquid and I'll squirt this in, because this is going to give us some suds, and this makes the reaction a bit more dramatic and a bit more visible. So if you want to, you can use food colouring. You don't have to. It just colours the reaction, or colours the suds that will come out. And finally, I'll put in my potassium iodide. So we can see it takes place almost immediately. And we have this characteristic colour which is given by iodine, which isn't actually produced in the reaction, but it will be an intermediate as the decomposition of hydrogen peroxide goes to completion. The characteristic test for oxygen is to show that a flame will burn brighter in it, or will relight a glowing splint. So as I touch this into the bubbles, you can see that that flame glows that bit brighter, and we can show that oxygen is present.
The pharmaceutical industry arrived in Ireland probably in the late 60s, early 70s, and in those 40 years that it's been in Ireland, it's responsible right now for 1 billion of corporate tax. It's responsible for 50% of our exports. It employs 25,000 people directly, with another 25,000 in service support. So it's quite important for Ireland to retain that industry and to support it, and that's what SSPC is doing.
In this I have a mixture of ethanol and water, and I have some copper sulfate salt. And you can show very dramatically the characteristic colour of the copper salt. We get a lovely green flame.
What do you got for us here?
Okay, so this is Brian.
Hi, Brian.
Hi, how are you?
Nice to meet you. Thanks for coming in tonight.
Brian is going to help me this evening. So
Yes.
what we have here is something called liquid nitrogen.
Great. Oh, great.
Now, nitrogen is actually, we're all breathing in nitrogen at the moment.
Oh, thank God.
78% of the air we're breathing in is made up of nitrogen. So it's perfectly safe.
Great.
More or less, depending on what you do with it. So liquid nitrogen is really, 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 really cold. So what we have in here is minus 196 degrees. So that's why you'll see it. Don't worry. I won't let him into any of it.
No, it looks really safe.
Yeah, it's super safe. Yeah,
I believe
absolutely.
that.
I'm glad you're feeling that too.
Yeah, I'm feeling
actually,
really
we might put that on you in a minute. So it's minus 196 degrees. It's really cold.
Yes, I can
Have you
sense
ever boiled the kettle, Ryan? Made
Yes,
a cup of tea?
I have, a couple of times,
Excellent.
yes.
Once or twice. Okay. So when we're boiling the kettle and we make a cup of tea, we see steam. So you can see it boiling there, and all this vapor that's coming off. This is the nitrogen gas. It's so cold, this room feels like a furnace to it. And as such, it's actually boiling off and evaporating off. So what is going to happen is I'm going to pour the liquid nitrogen into this bottle. Now this bottle is used for pressurized drinks containers.
Like vodka?
No, unfortunately, no. Fizzy drinks. Fizzy,
okay.
Vodka and Coke. Okay. So
Only in Ireland would that get a cheer.
you're going to see the nitrogen evaporating off and splashing a bit as I'm pouring it. That's why Brian is wearing a face
Brian, are you
shield.
okay? Are you good at this?
Good,
They don't value me as much, which is why I don't get the shield. Okay.
Yeah, I was thinking about that. Do you want to borrow mine?
No, you're good. So I'm going to keep pouring. We want to get it up to a level. We're not there yet, nearly there. And you can see it's quite difficult when you're pouring it because it's actually boiling off so fast. Even though I'm putting in what feels like an awful lot, it's actually taking a good while to go in.
Yeah.
So we actually use this all of the time. Is anyone here from the countryside? No one. No culture. Okay, maybe a few cultures. So you see this in the countryside a lot. The AI man will come around with the straws
Yes.
for the cows and the bulls.
For the stuff that he does, yeah.
Absolutely.
Good man
And we
himself.
use it to preserve our food, and we use it to freeze off warts and verrucas.
Now, what's happening now?
Okay, so now this is going to be the dangerous bit.
Yeah.
So when I cap this off,
Yes.
we're essentially making a mildly explosive device. Now, don't panic. Don't
bomb.
worry. Mildly. You're fine. We're all fine. Okay? So, when I cap this off,
Yeah.
Brian is going to place it into this bin. Yeah, I'd leave that
Definitely
on.
leaving this
Excellent,
on.
Excellent
Yeah,
idea.
into the bin.
Place it into the bin.
Yeah.
You're going to grab one bin of ping pong balls and you're going to throw yours in first. Apparently, you're more valuable than I am.
I doubt that.
I don't know.
No, here, you do
And
it.
then I'm going to pour my ping pong balls in immediately after, and then
Yeah.
we're both going to flake over there.
To run.
And
Okay.
good luck. Okay. Are we ready? What do you think? Yeah? Okay. Absolutely. We're all set. One.
What?
Oh, hang on.
Fingers in the ears, everybody. Cover them, not in the ears. Cover them.
Oh, sorry, guys.
Yeah, I love when you drop stuff and you're about to let off a bomb.
Nerves,
That's good.
guys. It's
That's
the
reassuring.
nerves. Steady hands. I need steady hands.
Yeah,
Okay.
yeah. No, you're doing great there with the old bomb disposal
I
unit.
am. I'm doing super.
Okay.
Okay.
So,
After you.
oh, sorry, you go.
Perfect. Okay.
Can we see it again? Is it possible to see it again in slow motion? That was great. That's the happiest bomb in the world. If only we
Next
could
time
have
we do
peace and love around the world with
rainbow
those sort of
ping pong
bombs.
balls next
Yeah,
time.
that's great. Thanks for the ping pong ball. So I have no idea what happened, but I have to say I'm looking forward to picking them all up myself as we say goodnight. Thanks very much for our friends in the science experiment, ladies and gentlemen. That's it for tonight. I'll see you back on RT Radio 1 next Monday morning at 9 a.m. and back here next Friday night for the Late Late Show. And on that bombshell, as Mr. Partridge would say. Thank you for watching and good night.
All of our focus is geared towards tackling problems which arise in the area of how we handle pharmaceutical solids. And by pharmaceutical solids we mean the materials at the stage in which they become powders, and further those powders are then blended and compacted into the form of tablets. So most people who take drugs of one sort or another, medicines of one sort or another, they're nearly all taking them in the form of tablets. So the whole business of the SSPC is to look at current and future methods whereby these tablets can be manufactured in a process which is both efficient from a manufacturing point of view and also very efficient from a user, from a medical point of view, so that when these tablets are ingested, for instance, by a patient, that they act in the way in which they're supposed to act.
Phosphorus P and potassium chlorate KClO3. A dusting of the red phosphorus, yeah, something like that, and somewhere in the middle. So that's what I have there now. Okay. Okay. That worked around, thankfully, and everything's fine. My name is Brian D'Souza. I'm a Senior Research Fellow at the University of Limerick, and we're here in the SSPC labs. We were asked by Pfizer to look at one of their key processes. We examined one of their key medicines. We've managed to improve process efficiency, throughput. We have reduced the time of the manufacturing process, and we've reduced the waste. So that was a terrific result for us. The pharmaceutical industry is vital to Ireland. To be nominated for this award is a huge recognition. It recognises the excellence of not only the researchers here in the SSPC, but also the Process Development Centre in Pfizer. But more importantly, it copper-fastens the reputation of Ireland as a centre of excellence for pharmaceutical manufacturing.
finely dispersed corn flour is highly, highly flammable. So we'll just demonstrate it here. And you can see the very finely dispersed particles, and that also allows for a lot of oxygen in between the finely dispersed particles in relation to the surface area. So that leads to greater flammability.
The first thing to bear in mind is that pharmaceutical manufacturing is in transition. It's changing the way it does things, it's changing the way in which it manufactures medicines, some new medicines and some old medicines. What's remarkable really about the SSPC is that it's not any one company. It's a collection of people who are looking at new ways to manufacture medicines. So really we're looking far into the future.
So I switch on the gas, and this is our methane gas supply, and the gas bubbles up through your washing up liquid and water solution, creating bubbles. So this clearly and dramatically illustrates how a very small amount of gas can produce a very, very big flame. And we can see these are floating very lightly because methane is lighter than air, it's less dense than air. So we'll just have one more go. And there's a very strong heat off of the flame. So we can see here, my arm is outstretched well away from me. I light the bubbles, nothing else. And I get a very spectacular demonstration.
What we do in SSPC and what our researchers do is we focus on the fundamental issues and try and apply those in a real-life industry setting to deliver cost savings for the companies. We have testimonials from our companies on what our research has meant to them. Some of them have told us that our research has delivered tens of millions of dollars of savings to them. Others have said to us that our research has led to them retaining significant numbers of jobs in the Irish economy. So in terms of job retention, job creation and cost effectiveness to the industry, that's where our impact has been most.
In this I have kind of a 2 to 3 ratio of ethanol and 20 volume, 6% hydrogen peroxide. And hydrogen peroxide is an oxidizing agent, and ethanol burns quite easily. It's very highly flammable. I'm going to light this, and I'm going to take some potassium permanganate, which is also a very, very powerful oxidizing agent, and I'm going to sprinkle some of the potassium permanganate into this flammable mixture. It will cause a series of loud bangs or pops as more oxygen is liberated. Using this. So because of the ethanol, it's difficult to see flame there, but it is.
I would like to see the SSPC in future become a globally recognised centre of excellence for research in pharmaceutical innovation.
When you bring complementary skills to a problem, such as engineers, chemists, pharmacists, and you work on the problem together as distinct on working on them from a silo mentality perspective, you deliver a greater result. And that's what we've managed to capture in SSPC. We've managed to get the pharmacists, the chemists, the engineers to look at the problems from different perspectives, and as such, we've delivered results there.